Am I audible?
Yes, sir.
So up to last class, we have finished this capacitor. We're doing this question. This was the initial condition that you have a parallel plate capacitor. Initially, you have air in between the plates, which is connected to a cell. The voltage of the cell is V. A cell of potential difference V0. The capacitance in air was epsilon naught A by D, voltage was V0, charge was C0 V0, potential energy was half C0 V0 square. That was the initial condition. Then what we did is we introduced a dielectric slab between the plates of capacitor. And then we said that battery remains connected. Just compare capacitance, potential difference, charge, energy. And we saw that capacity increases on introducing a dielectric slab. Potential remains constant. Charge increases. Potential energy also increases. Now the next part in the same question is, this is the initial condition. The second final condition could be a dielectric slab of constant K is inserted between plates. Inserted between plates. And battery is disconnected. Battery is disconnected for now. So when battery remains connected, then this is the voltage will remain constant. But when you disconnect the battery, this is capacitor. This is the cell. You disconnect the cell. Then voltage cannot remain constant because for voltage to remain constant, battery should be connected with the circuit. Now you remove the battery. On disconnecting a battery, this is the charge which becomes constant. Charge becomes constant means this was the initial condition. When you have air in between the plates and the batteries remain connected, the charge stored in the capacitor is C0 V0. And now this is the final condition. We introduce a dielectric between the plates and disconnect the battery. Now voltage will change, capacity will change, energy can change, but charge will remain constant. Remain constant means charge in this condition will be same as that of charge in this condition. So you can say, first let's see, charge will remain constant. Charge will not change, charge will remain constant. So the first thing is capacitance. Capacitance is K epsilon naught A by D. You can write this epsilon naught A by D as C naught. So your capacity becomes Kc naught. So when the battery is disconnected, capacitance C will be Kc naught. So capacity increases. Let's call it C prime. Now, if you want to calculate voltage, so to calculate voltage, we'll be using charge. Charge in the final, this condition will be equal to charge in this condition, Q naught. So you can say that Q will be equal to Q naught, which is equal to C naught V naught. So when you introduce a dielectric slab, but you disconnect the battery, then capacity, energy, voltage, everything can change except charge. Charge will remain constant, Q prime. So if I have charge, I have capacitance, how will I calculate the potential difference? Alia, you have charge, you have capacitance. How to calculate the potential difference? Alia, how to calculate potential difference if you have charge and this capacity? Alia, from the next class onwards, na, just mic I need your mic. from the next class onwards. V prime will be, it will be Q prime divided by C prime. So how much is Q prime? Q prime is Q naught. How much is C prime? C prime is KC naught. And what is Q naught by C naught? See, Q naught by C naught is V naught. So what happened with the voltage? Voltage is constant or voltage decreases? Alia. Initially, voltage is this V naught. When you introduce a dielectric slab and remove the battery, then voltage is this V naught by K. So what is the status of voltage? It's constant or it decreases? See, earlier it was V naught. Now it is V prime, and V prime is V naught divided by something. So it's constant, it is increasing or it is decreasing? Alia. Yes, it will decrease. Na? You're dividing by something, so it will decrease. So voltage will decrease. Third point, what about charge? Charge, as we have already discussed, that charge will not change. Charge will remain constant. The next thing is energy. You're supposed to calculate energy. So how to calculate energy? Energy is half CV square. So the energy is half C prime V prime square. So half C prime. How much is C prime? C prime is KC naught. So instead of C prime, you can write KC naught. How much is V prime? It's V naught by K. So it's V naught square divided by K square. So this K will cancel this square, and U prime is half C naught V naught square divided by K naught. And what is half C naught V naught square? Half C naught V naught square is U naught. So U prime is U naught by K. So this is U prime, which is U naught divided by K. Energy in free space divided by the dielectric constant. Is it clear? Noah, Unib, Arpit?
Yes, sir.
Yes, sir.
Can you tell in brief what are they?
Yes. In the last class, I left at this condition that you introduced a dielectric slab and battery remains connected. Now, the
Yes.
next condition could be you introduce a dielectric slab and you remove the battery. So when you remove the battery, then charge will remain constant. Charge will not change. Charge remains constant means this is the initial condition when you have air in between the plates and battery is connected. So the charge in this condition and charge in this condition means when you introduce the dielectric and remove the battery, the charge will be same. Charge will remain constant. We calculate capacitance. Capacitance is K epsilon naught A by D, KC naught. We calculated voltage. To calculate voltage, I use charge. That charge will remain constant. Q prime is Q naught, which is C naught V naught. V prime is Q prime by C prime. So it's Q naught by KC naught, which is V naught by K. So V prime is V naught by K. Potential decreases. And charge does not change. Charge will remain constant. If you want to calculate energy, then it's half C prime V prime square. It's half KC naught V naught square by K square. Square will cancel this K. And this is half C naught V naught square by K. So energy will decrease. So when you introduce a dielectric slab and you remove the battery, then capacity increases, voltage decreases, charge will remain constant, and energy will also decrease. Note it down. This is the next case. This is first case. This is second case. Written? Can I change the slide?
No, sir, 1 minute.
Miraj, clear? Any doubt?
Yes, sir, clear.
Bhishma, any doubt?
No, sir.
Yes, written. Okay, after this, the next topic is series and parallel combination of capacitor. And that's the last topic of this chapter. Series and parallel combination of capacitor. Series and parallel combination of capacitors. Now see, what does series and parallel combination of capacitors means? Before starting series and parallel combination, you should know division of charge and division of voltage. Division of charge and division of voltage. We do series and parallel combination using this division of charge and division of voltage. Now let's see what does division of charge and division of voltage means. and when charge and voltage divides. So see first the division of charge. So division of charge. Charge divides due to branching. Charge divide due to branching. So whenever you have branches in your system, your charge will divide. It always divides due to branching. So say this is your wire. This wire divides into two parts. It divides into two branches. So this is the charge Q1 coming. This charge Q1 divides into two parts, a part Q3 and a part Q3. It divides into two parts. So whenever you have branch, charge will divide. You can write that Q1 will be equal to Q2 plus Q3. Charge will divide into two parts. If you don't have branches, like the charge Q1 is coming from here, there is no branch, so charge will not divide. So whenever you have branch, your charge will divide. Without branching, charge will not divide. So if I am drawing this diagram, Anshika, will charge divide in this case?
So I didn't get you.
Okay. See, charge divides due to branching. Whenever you have branches in your wire, branching means there is single wire, it divides into two wires. When a wire divides, when you have branches, then charge will divide. So here some charge Q1 is coming. It divides into two parts. One is Q2 and other is Q3. Here there is no branch. See, it's a single wire. There is no division in charge. I'm asking in this question, will the charge divide?
No, sir, the charge won't divide it.
Charge won't divide. Right? Same thing. There is no branch. If I give you some capacitors, this is capacitor C1, this is capacitor C2, this is capacitor C3. Noha, all these capacitors will have same charge, or they will have different charge.
So same charge.
Why?
So because there is no branching.
There is
only
no
single.
branching, so charge will remain same. So here also charge Q, here also charge Q, here also charge Q. Charge will divide only if you have branches. If you don't have any branch, then your charge will not divide. But if I draw this diagram, now I have three capacitors, C1, C2, C3. What will happen now? Charge will remain same or it will divide again? Saifullah, what will happen now? Charge will remain same in both the
It
all
divides.
capacitors divides. So charge Q1 is coming here, it will divide. This will be Q2 and this will be Q3. What will be the relation between Q1, Q2 and Q3, Minashi?
Q1 equal to Q2 plus Q3.
Good. So that is the division of charge. After division of charge, the next is division of voltage. Voltage does not divide due to branching. Let's see, when we have same voltage, it divides due to capacitor or resistor. We'll understand this concept through this example. Let's say I take a single wire. If I take this wire, then potential at each and every point on the wire is same. Here, here, here. At every point, potential will remain same. Potential will not change. If you have a straight wire, potential will remain same. It's not necessary that wire is straight, even if there is branching. If you have a conductor, then potential at every point of the conductor will remain same. At every point potential is same, potential will not change. Potential will change when you bring a capacitor or resistor. Like in this wire, okay, I'm giving you this wire. I'm giving 3 points, one point A, another point B, another point C. Unib. A, B and C will have same potential or different potential?
सर बी और सी का सेम होगा और ए का अलग.
Arpit,
Sir, it will be same.
all will have same potential only. I'm not asking about charge, I'm asking about potential. All 3 points A, B and C will have same potential. VA will be equal to VB, which is equal to VC. All points will have same potential. VA, VB, VC, all will be equal. There won't be any difference in potential. Because if you have this is wires, na? When you have wire is a conductor. The surface of conductor is an equipotential surface. On every point potential will be same. VA, VB, VC, everything, everywhere
सर
potential.
तो जब ऐसे पैरेलल में होता है बी और सी में सेम होता है और ए में अलग होता है.
वो तब होगा जब capacitor. I'm not adding a capacitor. You know, wires. It doesn't matter in how many parts this wire will divide. At every point, your potential will remain same. VC, VD, VE, everywhere potential is same.
Okay, sir.
But instead of wire, if I give you a capacitor, see, this capacitor will offer discontinuity. If I say that potential over this point is VA, here potential will be VA again because it's straight wire. But due to this capacitor, now potential will change. Up to this plate, it's VA, and here it will be VB now. Potential gets changed. So whenever you have a capacitor or a resistor, that capacitor or resistor will offer some discontinuity, and due to that discontinuity, the potential will change. Here it's VA, and here it will be VB. Potential is not same. But we are interested in potential difference. We need, see, this VA is potential. This VB is potential. But in circuits, we need potential difference. And potential difference is this VA minus V. Is it clear? Point A and B have potentials VA and VB, and the potential difference will be VA minus VB. That's the potential difference between points A and B. So I'm giving you one more example. I'm giving you these two capacitors. You have to decide whether these capacitors will have same charge or not. Mehraj, these two capacitors will have same charge or different charge?
Same.
Why? Why charge will remain same? Why charge will remain same, Mehraj? Mehraj बहुत सुनेगा. Mehraj है. Arpit, why this charge will remain same? Arpit, why this charge will remain same? Arpit, you are not audible. Anshika, why this charge will remain
because
same?
यहाँ पे branching नहीं हो रही है. That is why.
There is no branching, so charge will remain same. Here Q, here Q. Now we have to decide whether the voltage or potential. See, potential difference and voltage is the same thing. Now we have to decide whether there is a potential, whether the potential difference across both the capacitors is same or different. Here this is VA. What is the value of potential at this point? Ishma. Ishma, this is VA. Then how much is this one?
Yeah.
VA. Will this be VA? This is also VA.
No.
Why? Because you have a capacitor. Huh? Capacitor will offer discontinuity. Due to this, capacitor potential will change. This is VB. And here, if this is VB, then here this is also VB. Because it's straight wire. Will this point will have potential VB? Will potential here will be VB or something else? Anshika? This is VB, this is VB.
Something else.
Something else. Let's call this as VC. So here the voltage is VA minus VB. Here the voltage is VB minus VC. Voltage or potential difference is changing. It's VA minus VB, it's VB minus VC. So when you have capacitors in series, then potential difference or voltage will divide. Voltage is dividing, but charge will remain same. I'm giving you another example. Just look at this figure and tell me, charge will remain same or it will divide?
It's getting divided.
Charge will divide. Both capacitor, this branching. So some charge Q comes over here, it divides into two parts. There is Q1, this is Q2. So capacitors will have different charge. What about the potential? If I take potential at this point is VA, will this be VA? Saifullah, will this
Yes,
be
sir.
VA? Will this be VA?
Yes.
This will be VA.
No. It will be
No.
something else.
Something else. Think again. See, when potential remains constant, potential remains same when you have a
Yes,
straight
it will
wire.
be same, sir.
It will be same. Yes, Alia, you are right. This is same. And what about here? Is it VA or something else?
That's something else, sir.
That's VB. It's VB. Let's come. So potential difference across both the capacitors is different. Across V1, it is VA minus VB. V2, this is VA minus VB. So potential difference is different or same? Potential difference is same. So to solve circuits, you should be able to decide whether in a given circuit, in a given branch, charge is dividing or it's same, potential is dividing or same, voltage is same or voltage will divide. Then only you can solve circuits. Note it down and tell me your doubts. Mazia, clear?
सर कैपेसिटेंस की जगह रेजिस्टेंस होती है ना सीरीज पैरेलल.
हाँ, कैपेसिटेंस एंड रेजिस्टेंस का सीरीज पैरेलल मोर और लेस एक सा होता है, थोड़ा सा डिफरेंस है बहुत. तो जो सर्किट तुम कैपेसिटर में करोगे वो तुम रेजिस्टर में भी करोगे.
सर तो क्वेश्चन में मतलब रेजिस्टर्स ही आएंगे.
क्या सर्किट्स में अभी रेजिस्टेंस नहीं है, नेक्स्ट चैप्टर में
मैं
रेजिस्टेंस
कह रहा हूँ कि क्वेश्चंस में तो जैसे बोर्ड और रेजिस्टर्स ही होंगे ना, कैपेसिटर्स भी होंगे.
resistors be capacitors be both. In chapter 2 you have series and parallel of capacitor. In chapter 3 you have series and parallel of resistor, and in chapter 3 you will study capacitor and resistor combination also. See, if you don't understand the division of charge and voltage, then you can't do circuits. To analyze series and problem, you should know how to analyze the division of charge and potential. We'll be doing whole series and parallel combination using this charge and potential. Alia, what topic are you doing in your school? Okay. Okay. And when will your vacations will end? And Noha, what topic you were doing in your school?
So done with chapter 3.
Okay, done with chapter 3. Current is over, huh?
Yes.
It's still your summer break or?
Yes, sir.
Excuse me, sir.
Yes, Arpit.
Sir, we will not do cylindrical capacitor.
We will do, but not now. After finishing this thing.
Sir, it is difficult. I don't know why.
We'll do cylindrical capacitor. Cylindrical capacitor is not a part of CBSE syllabus. Not a part of JEE syllabus. Only NEET it can be asked. Yes, everyone written. Saifullah, Ishma.
No, sir, 1 minute.
Written? Okay. Now let's start with the series combination. This was the division. This division will be using in series combination. The next is series combination of capacitor. So if I say that capacitors are connected in series, that means capacitors are connected in this fashion. This is first capacitor of capacitance C1, C2, C3, Cn. This is how capacitors are connected in series. So in this case, what will happen? Charge will remain same or it will divide? Mazia, when you look at this diagram, charge will remain same or it will divide? Mazia, in all, Alia, in all these capacitors, charge will remain same or it will divide? Mazia, see, there is no division, there is no branching here. See, if some charge Q travels from the cell, then the same charge will go here, same charge will go here, same charge will go here, same will go here, and same will go here. There is no division of charge. Charge is not dividing. Charge will divide when you have branching. There is no branching, so charge will not divide. If voltage of battery is V, then voltage will divide. This voltage divided into n parts, V1, V2, V3, Vn. So in series combination, charge stored in each capacitor is same, while voltage divides. So that is series combination. Same charge is stored in each capacitor, but voltage will divide. If I say this is the total voltage of the battery, this voltage will divide into n parts. It's V1, it's V2. So when capacitors are connected in series, charge stored in each capacitor is same. This have same charge Q, this have same charge Q, this have same charge Q. But voltage is different. Say if the voltage of battery is 100 volt, then this 100 volt will divide into all capacitors. When you sum up V1, V2, V3, Vn, you will get 100. Your task here is to calculate equivalent capacitance. Equivalent capacitance means if you remove all these capacitors, if you replace all these capacitors by a single capacitor, and you say the capacitance is C equivalent and voltage is, this is equivalent capacitors. Remove all capacitors and replace them by a single capacitor. That's the equivalent capacitance. The charge stored in this equivalent capacitor is C. The total voltage across this equivalent capacitor will be V. That's my equation. The next task is you have to relate V, Q, and C equivalent. Hishma, how will you relate this Q, C equivalent, and V? Is there any relation between Q, C equivalent, and V?
C equals Q by V.
Yeah, C is Q by V. So you can write Q is C equivalent multiplied by V. So you can write that your V will be Q by C equivalent. So instead of this V, you can write C equivalent by V. Alia, we remove all these capacitors and replace them by a single capacitor. The name of this single capacitor is C equivalent. The charge stored in this equivalent capacitance is Q, and the voltage across this equivalent capacitance is V. So this single capacitor replace all these n capacitors. So V is Q by, and Q is C equivalent into V. This is the formula for capacitor. Charge is capacitance into voltage. You can write that V is Q by C equivalent. In this equation, instead of this V, I can write its V is Q by C equivalent. See, this is V1. What is V1? V1 is voltage across first capacitor. Across first capacitor, charge is Q, capacitance is C1. Only Can you express V1 in terms of Q and C1? Only charge stored in first capacitor is Q.
So
Volt
into capacitance.
V am asking V1 in terms of
Then
Q and
V1
C1
into capacity C1.
into C1. By C1. Q by C1. What will be Q2? Mazia. V2, sorry. V1 is Q by C1, Mazia. What will be V2?
Q by C2.
Q by C2. Similarly, you can write Qn, Vn, which is Q by C1. This Q, this Q, this Q, this Q will get cancelled out. 1 by C equivalent is 1 by C1. 1 by C2 is 1 by C1. This is how we calculate equivalent capacitance. 1 by C equivalent is 1 by C1 plus 1 by C2 up to 1 by C. If you have two capacitors, then you can derive a shortcut method. For two capacitors, you can write C equivalent as C1 C2 by C1 plus C2. This will save some time. So the first task was to calculate equivalent capacitance. This is how we calculate equivalent capacitance when capacitors are connected in series. Does anyone remember? For resistors, this was formula for series or for parallel?
For parallel.
For parallel. For resistors, this was the relation for the parallel combination. But for capacitors, this is the relation for series combination. Next. The next is I need total potential drop across the circuit or total voltage across the circuit. See, the total voltage across the circuit is the voltage of the battery. It's V. That is the total voltage across the circuit. That's V. Next, I need total charge stored in the circuit. Total charge stored in circuit. See, total charge, you can represent it by Q. What is total charge? Total charge is total capacitance into total voltage. What is total capacitance? Is C equivalent. What is total voltage? It's V. So Q is equal to C equivalent into. This is the total charge. After total charge, I need charge stored in each capacitor. In each capacitor, charge stored is same. See, all capacitors are connected in series. So charge stored in each capacitor is same. Because in series, there is no division of charge. Charge will not divide. Charge stored in each capacitor will be same. After charge stored in each capacitor, I need energy stored in each capacitor. Energy stored in each capacitor. U1. Alia, just tell me one expression for calculating energy. Alia, expression for yes. One is half CV square. You can also use Q square by C. So energy stored in first capacitor is half Q square by C1. Energy stored in second capacitor is half Q square by C2. You can also calculate energy stored in nth capacitor is half Q square over C. This is the energy stored. Next, we need total energy stored. To calculate total energy stored, just keep on adding individual energies. U1 plus U2 up to U1. So U1 is half its Q square over C. Half Q square over C2. It's half Q square. So you can write this is Q square over 2, 1 by C1, 1 by C2 up to 1 by C. And this 1 by C1 plus 1 by 2 plus 1 by Cn. What is this, Minashi? What is 1 by C1 plus 1 by C2 plus 1 by Cn?
1 by C equivalent.
1 by C equivalent. So that will be Q square by twice of C. So in series combination, numericals on series combination, the first part of the question will be to calculate equivalent capacitance. After calculating equivalent capacitance, you will calculate total voltage across the circuit. Then you will calculate total charge in the circuit. Then you will calculate charge stored in each capacitor, energy stored in each capacitor, and total energy stored in the circuit. You can calculate one more thing. You can even calculate voltage across each capacitor. You can also calculate voltage across each capacitor. Yes, what will be the expression for voltage across each capacitor? Ishma, will you tell? Charge is Q, capacity is C1. What will be the expression for V1? Voltage across each capacitor. So V1 will be Q by C1, na? V2 will be Q by C2. Vn will be Q by Cn. This is how we calculate voltage. So across each capacitor, voltage is constant. For first capacitor, it's Q by C1. For second capacitor, it's Q by C2. For nth capacitor, this is Q by Cn. So this is how we calculate voltage across each capacitor. Q by C1, Q by C2, Q by Cn. Note it down. We'll do one numerical on this. Muneeb, written?
Yes, sir.
Saifullah, written?
Yes, sir.
Okay, so let's do first numerical. Now, first, very straightforward. So the first numerical, we will take two capacitors. One capacitor of 5 microfarad, another capacitor of 10 microfarad, and I connected them in series with a cell of 10. See, this is a very simple circuit, but all complex circuit will have different combination of this circuit. Like in a complex circuit, you can have like 5 combination of 2 capacitors. So if you know how to solve this circuit, then complex circuit won't be an issue for you. We're supposed to calculate first part, equivalent capacitance. Second part, total voltage. Third part, total charge. Fourth part, charge stored in each capacitor. Fifth part, voltage across each. Energy stored in each. Energy stored in each capacitor. Now let's start your calculations. C equivalent, Mazia. Mazia, you have two capacitors. One is C1, which is 5 microfarad. This is C2. How to calculate C equivalent? Mazia, tell me formula for C equivalent. See that series combination of two capacitors. The formula for calculating equivalent capacitance. Vishwa?
C1, C2 by C1 plus C2.
Yes. C1, C2 by C1 plus C1 is 5, C2 is 10, C1 is 5, C2 is 10, 50 by 15. So 10 by 3. It's not 3 by 10, it's 10 by 3. Alia, you calculated 1 by C equivalent. Then take inverse of it. And the unit is microfarad. Now, how to convert this microfarad into farad? Noah? How to convert this microfarad into farad?
So multiply by 10 raised to the power minus 6.
So you can say C equivalent will be 10 raised to the power minus 5 by 3 farad. That's C. Once you have C equivalent, you can calculate total voltage across the circuit. So, Arpit, what will be the expression of total voltage? How much is total voltage across the circuit? Arpit, what is the expression for total voltage across the circuit? See, this EMF of cell is the total voltage across the circuit. So total voltage across the circuit is 10 volt. That is the total voltage. Third. Next, you need charge stored, total charge stored. Anshika, relation for calculating total charge. Anshika,
So
expression for total
Q1
charge.
plus Q2.
Nah. So charges is same. Not Q1 plus Q2, but C equivalent into V. C, good idea, Alia. C equivalent is 10 raised power minus 5 by 3 into 10. So that's 10 raised to the power minus 4 by 3. Fourth part. After total charge, you need charge stored in each capacitor. What is the expression for charge stored in each capacitor? Q1, Q2. What will be the value of Q1 and Q2? Unib. We know total charge. What will be the expression for charge stored in each capacitor?
Sir, 10 to the power minus 4 upon.
Why?
Sir, charge same रहेगा branch.
Charge will remain same. Nice. There is no branch. Good. 10 raised power minus 4 by 3. After charge stored in each capacitor, I need voltage across each capacitor. What is the expression for calculating voltage, Minashi? We have charge. Sorry.
Q by C1.
Q by C. So that's Q1 by C1. How much is Q1? Q1 is 10 raised to the power 4 by 3. C1. How much is C1? 5 microfarad. Minus 6. So that is 100 by 3 into 5. Gets cancelled out 20. So that is 20 by 3 volt. For V2, you can do Q2 by C2. Q2 is this 10 raised to the power minus 4 by 3. And C2 is 10 microfarad. 10 into 10 raised power minus 6. So this will be 10 by 3 volt. Can you guess what should be the result if I add V1 and V2? Arpit? Arpit, what will be the result if I add V1 and V2? Arpit, you're not audible. See, the voltage of battery is dividing into two capacitors. Na? So if I add V1 and V2, I should get back the 10 volts. So let's see. If I add V1 and V2, V1 is 20 by 3, V2 is 10 by 3. When I add them up, it becomes 30 by 3, and 30 by 3 is 10 volt. So that is the total voltage, it's 10 volt. Is it clear? Next, I need energy. What is the expression of calculating energy? Mazia, just tell me one expression to calculate energy. Correct? Saifullah. Expression for calculating energy.
1 by 2 Q square by C1.
Very good. Q square by C. For U2, you can do 1 by Q. You have Q, you have C2. You can do this calculation. Okay, if I ask you to calculate the total energy, Noah, then how will you calculate total energy? You know U1 and U2. Then how to calculate total energy? Noah Akhtar. We have U1, we have U2. How to calculate the total energy? Noah.
So Q square by 2 C equivalent.
You can do two things. Na? You can either add U1 and U2. Or you can do this is half Q square by C equivalent. Good, Alia. Put it. Any doubt, Minashi? Noha?
No, sir.
Is it clear? Alia, all steps clear. The next is this is over, this is over. Now see parallel combination. Parallel combination of capacitor. Parallel combination means this combination, this geometry. This is capacitors and you need to connect them with a cell. Capacitance is C1, C3, the voltage of the cell is V. So can you tell me, Mazia, charge will remain same or charge will divide in all of them? Mazia, charge is in each capacitor will remain same or good, it will divide because it's a branching. Huh? So this charge is Q, this divides into three parts. It's Q1, it's Q2, it's Q3. Charge will divide. What about the voltage? Voltage will divide or will remain same? Ishma. In this particular combination, voltage will divide or will remain same? Voltage, Ishma.
It will divide.
It will not divide. See, we did this thing, na? We did this thing. See, if two capacitors are connected in this way, end to end, then voltage is same, VA minus VB, VA minus VB. So voltage will not divide, voltage will remain same. So in parallel combination, voltage across each combination, across each capacitor is same. While charge divides. Across each capacitor, voltage will remain same, but charge will divide. So you can say that Q will be, it's Q1 plus Q2 up to Q1. This is Q, Q1 plus Q2 up to Q1. Q you can write its C equivalent into V. What will be the expression of Q1 in terms of C1 and V? Minashi?
Sir.
Expression of Q1 in terms of C1 and V. Minashi.
C into V.
C
C1
into
into
V.
V.
C1 into V. What will be Q2? C2 into V. What will be Q3? C3 into V. Now see, you can cancel this V from both the sides. You get C equivalent is C1, C2, C3. This is same as series combination of resistors. So that's the formula for C equivalent. After C equivalent, he will ask you to calculate total voltage. Total voltage is V. Then the next part is total charge. What will the expression for total charge, Saifullah? How to calculate total charge? You know total capacitance, you know total voltage. How to calculate total charge?
Q1 plus Q2.
Nah. You have total capacitance and total voltage. Noah. How to calculate total charge? C equivalent into V, na? Total capacity into total voltage. That's Q. C equivalent. After total charge, you can calculate charge stored in each capacitor. Charge stored in each capacitor. See, the charge stored in each capacitor will be Q1 will be C1V, Q2 will be C2V. If you want voltage across each capacitor, then it will be same as that of voltage of battery. Voltage across each capacitor. V1 equal to V2 equal to Vn equal to V. Voltage across each capacitance. Then you need energy stored in each capacitor. U1 is half C1 V1 square. Then you have U2, which is half C2 V2 square. Then you have UN, which is half Cn Vn square. If you want total energy, then just add them up. To calculate total energy, just add them up. U1, U2, UN, which is half C equivalent multiplied by V square. This is it. That's the total energy. This is how we calculate the total energy stored in the capacitor. Half C equivalent to V. Is it clear? Mazia, Ishma, note it down. We'll do one numerical order.
So the voltage will be same, right? So why
Yes,
are we
voltage.
taking V1 and V2 like that?
But I wrote them as V1, V2, Vn as V1.
Okay, sir.
I keep their names as V1, V2, and then I say that it is equal to V1. Mazia, written. Okay, so let's stop here. We'll continue this in the next class. Questions on parallel combination we'll do in the next class. If you have any doubts, we can discuss it, right? Class is over. If you have doubts, we can discuss.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.